All right, this is going to be part 2 of the video. I am starting with the unit circle that we had just drawn previously in part 1. I just erased some stuff. Okay, so let's start back with this unit circle here. And we now have our trig functions. That's where we left off, right? Okay, so we have our trig functions. And we know even more information than we thought about the sine, cosine, and tangent ratios in the triangles that we just talked about, right? So if we know the measure of theta, we can calculate the side lengths of those triangles. So let's say we have an angle of theta equals pi over 3. Let's see, we have an angle of theta equals pi over 3. So we rotate it to about here. There we go. That looks like pi over 3. We have our point on the unit circle where that terminal side intersects, and then we drop down an altitude. So let's go ahead and pop this triangle out so that way we can get rid of that. Pop this triangle out so that way we can examine what's really going on here. There's a triangle over here. And theta is here. Theta is pi over 3. We know that since it's the unit circle, the measure of the hypotenuse is going to be 1 because the radius of a unit circle is always going to be 1. And then let's see if we can figure out any of the other information about the triangle. In the unit circle, we can use our previous knowledge of geometry to find the lengths of every side of this triangle. So let's remember the 30, 60, 90 triangle from geometry. So the 30, 60, 90 triangle, except this time instead of working in degrees, I'm going to work in radians if that's okay. So remember that 30 is pi over 6, 60 is pi over 3, and 90 is pi over 2. So I'm going to work in radians. But it comes from an equilateral triangle. So we start with an equilateral triangle with side lengths of 1, 1, 1, and angle measures of pi over 3, pi over 3, and pi over 3. This is an equilateral triangle. So if I drop an altitude, I have a new triangle that looks like this. This is still pi over 3. We didn't touch this. We bisected this angle. So now we have pi over 6, pi over 6. And then this one's still pi over 3. I now have a 90-degree angle here and a 90-degree angle here. This one remains 1. This one remains 1. This one has become 1/2 because the altitude bisected the base. And now we have two triangles, and we have found all of the angle measures and most of the side measures. We are still missing the length of this altitude here. So let's use the Pythagorean theorem to find the length of that last altitude. So we have the Pythagorean theorem is a squared plus b squared equals c squared. We know that c is always the hypotenuse, so let's go ahead and sub in that. A can just be, I don't know, unknown. How about that? And then b squared can be 1/2 squared. So let's go ahead and solve for what a squared is going to be. So we have a squared plus 1/4 is equal to 1. I'm going to move that 1/4 to the other side. I get a squared is equal to the square root of 3 over 4. When I take a square root, I'm going to have a equals plus or minus rad 3 over 2. I can see here that a negative 3 over 2 doesn't make sense because we are measuring stuff. So we are just going to accept the square root of 3 over 2 as our side length there. So now we have the measure of all 3 side lengths of this triangle over here. So I've got 1, I've got rad 3 over, whoa, it's a wild 3, rad 3 over 2, and then I've got pi over 6 over here and 1/2. I took all that information from this triangle over here. So because I'm going to be working, I'm going to erase this stuff. This was just an explanation to like jog your memory of the 30, 60, 90 triangle and where we're getting all this information. Okay, so now that we have the triangle all filled out, we are going to calculate the trigonometric ratios of this triangle. So first, let's calculate the sine. the sine of theta. Now remember, we are referring to theta. So theta is the angle that we are using to refer to opposite, adjacent, or hypotenuse sides. Okay, so in relation to theta, this is going to be the hypotenuse, this is going to be the opposite, and this is going to be the adjacent side. So the sine of theta is going to be the opposite over the hypotenuse side. So the sine of pi over 3, which is theta, is going to be rad 3 over 2 over 1, which reduces to just rad 3 over 2. The cosine of pi over 3, or the cosine of theta, or let's start the way we started before. The cosine of theta is going to be adjacent over hypotenuse. Theta over here. So the adjacent side is 1/2. Or let's do it the same way we did the other one. So we have cosine of pi over 3 is equal to, the adjacent side is 1/2, the hypotenuse is 1. So the cosine of pi over 3 is going to be 1/2. Now let's do the tangent of theta. Tangent of theta is opposite over adjacent. So we've got opposite over adjacent. So the tangent of pi over 3 is going to be opposite, which is rad 3 over 2, divided by 1/2. So that is going to be rad 3 over 2 divided by 1/2. When we divide by a fraction, we keep, change, flip, cross reduce. I'm going to get rad 3. Okay, so the tangent of pi over 3 is the square root of 3. So let's begin creating our common trig angles chart. So if you'll notice, I am now drawing in red, so this is going on your foldable. We have common trig angles. Okay. Radians up here and degrees over here, just in case you're not comfortable going between the two yet. I'm going to put both on here. And we have a chart that looks like this. And let's start filling it in with some common angle measures. So theta equals 0. When theta is 0, degrees are also 0. Theta equals pi over 6, which is the same thing as 30. Theta equals pi over 4, which is the same thing as 45. Theta equals pi over 3, which is the same thing as 60. Okay, and then we're going to fill in the quadrantal angles, which are going to be pi over 2, which is the same thing as 90. Pi, which is the same thing as 180. 3 pi over 2, which is the same thing as 270. And no! I'm going to make it a little longer. And 2 pi, which is the same thing as 360. Okay. Now let me just kind of clean this up because it's going to be on here as a reference. So I want it to look really nice. All right, there we go. So this is going to be our common trig angles chart, and we are going to use trigonometric ratios of sine, cosine, and tangent to fill it out, so that way you can start memorizing it. Okay, so we just calculated the trigonometric ratios for pi over 3. So in the pi over 3 column, I'm going to put the sine of pi over 3, which is rad 3 over 2. I'm going to put the cosine of pi over 3, which is 1/2. And then I'm going to put the tangent of pi over 3, which is the square root of 3. We're going to go ahead and do this again for pi over 6, pi over 4, and then we'll talk about the quadrantals, okay? So Now we are going to do it with the opposite angle, okay? So I'm going to go over here and erase my stuff here, erase my stuff here, erase my stuff here. What do I mean by I'm doing it by the opposite angle? So I'm just going to zoom in over here, and now instead of pi over 3 being theta, instead of pi over 3 being theta, pi over 6 is going to be theta. I'm changing my angle that I am looking at when I take these trigonometric ratios. So now theta is going to be pi over 6. Okay, and on the unit circle, if I were to show a rotation angle of pi over 6, it would look something like this. Pi over 6 is the same degree measure as 30 degrees, so it's going to be just a little smaller. Pi over 6. Okay. And I would be making my triangle, popping it out over here. And let's change this. This one would now become a little different. Okay. So we've got pi over 6. And remember, in special triangles, the side across from pi over 6 is going to be 1/2. The side across from pi over 3 is going to be rad 3 over 2. And the side across from the 90-degree angle is going to be 1. Okay, so now we have changed our theta to become pi over 6. And we are going to calculate those trig ratios now, okay? So looking at our triangle over here, we have the sine of pi over 6. It's going to be opposite over hypotenuse, which is going to be 1/2 over 1, which is just 1/2. We have the cosine of pi over 6 is going to be adjacent over hypotenuse, so that's going to be rad 3 over 2 divided by 1, that's going to be radical 3 over 2. And then the tangent of theta is going to be the tangent of pi over 6, which is opposite over adjacent. So that's opposite over adjacent. That's going to be 1/2 over rad 3 over 2. Cancel. I get 1 over the square root of 3. I have to rationalize the denominator. And I get rad 3 over 3. Okay. So these are now the values that I'm going to be putting into my common trig angles chart. Okay, so the sine of pi over 6 is, I go to the pi over 6 column, the sine of pi over 6 is going to be 1/2. The cosine of pi over 6 is rad 3 over 2, and the tangent of pi over 6 is rad 3 over 3. Okay. Let us look at the 45-degree or pi over 4 theta angle now. Okay, so I'm going to zoom in here and let's change theta to now be let's change theta to now be pi over 4, because that's the other one that we're exploring, pi over 4. So we're going to rotate pi over 4. So I start at the origin and I rotate pi over 4. Theta equals pi over 4. I'm rotating up to about halfway. Okay. So if I drop a little altitude here, I now have a triangle that looks like this. I have pi over 4 here, and then if I have pi over 4 here and 90 here, this one also has to be pi over 4. Why? Because it's a special triangle. It's a special 45, 45, 90 triangle. Okay. And if you ever forget about 45, 45, 90 triangles, they come from squares. I have a square, 90 degrees here, 90 degrees here, 90 degrees here, 90 degrees here. I have side measures 1, 1, 1, 1, 1. I cut it in half with a diagonal. I now want to find the length of the third side here. This has bisected this angle here, bisected this angle here, bisected this angle here, bisected this angle here. I have a new triangle that looks like this, 45, 45, 90. I have a 1 here and a 1 here. I'm trying to find the third side. I have a squared plus b squared equals c squared. So that's going to be 1 squared plus 1 squared is equal to c squared. That's going to give me 1 plus 1 is c squared. C equals the square root of 2. Okay. So I have this is going to be the square root of 2. Okay. So if I use that information, I have side lengths 1, 1, and the square root of 2. But I know that since this has to be 1, right, because it's in a unit circle with a radius of 1, I now have x here, x here. So I would do x squared plus x squared equals 1, 2x squared equals 1, divide both sides by 2, divide both sides by 2, x squared equals 1/2, square root both sides. I have x equals the square root of 2 over 2. Okay, so that's where we get those special triangle measures from. So if x is the square root of 2 over 2, I can substitute that over here. I have square root of 2 over 2, square root of 2 over 2. And these values are coming right from special triangles. Okie dokie. So if I'm calculating the sine, cosine, and tangent of pi over 4, right, this is my new theta. Theta equals, I have sine of pi over 4 equals opposite over hypotenuse. So that's going to be rad 2 over 2 over 1. That's going to be rad 2 over 2. The cosine of pi over 4 is going to be adjacent over hypotenuse. So that's going to be rad 2 over 2 over 1. That's rad 2 over 2. And then the tangent of pi over 4, pi over 4 is going to be opposite over adjacent, which is going to be rad 2 over 2 over rad 2 over 2. Anything divided by itself is going to give me 1. So I now have my important values to put onto the common trig angles chart. At 45, I have the sine of 45 is going to be rad 2 over 2. The sine of cosine of pi over 4 is rad 2 over 2. And the tangent of pi over 4 is going to be 1. I'm going to do the quadrantal angles, so 0, 90, 180, 270, and 360 in the next video.